Hello everyone, I am Brandon Ordonez from ECE31 and today we're gonna perform our experiment number 1 for our Power Electronics Laboratory, which is entitled Introduction to Circuit Modeling. The objectives of this experiment are to familiarize with the PSpice simulation software, to capture diagram of switching circuit, to model the switch based on the set parameters. Now, let us proceed with the experiment. The first part discusses about voltage-controlled switch in PSpice. First step is to open OrCAD Capture PSpice and click New Project. Choose the analog or mixed AD and name it as Experiment 1. Click the location. Click OK. Create blank project. Click OK. Now, let us build the circuit. Click Place, PSpice component and search. Type in the search bar S-brake and place the S-brake or the voltage controlled switch in the circuit. Click Edit, PSpice model, and edit the necessary parameters. Click Ctrl S. Next, click Place, PSpice component, source, voltage source, and pulse, and place it in the schematic. In the right pane, click the Place Part icon. You can also do it here. Since we could not find the desired component, we could place resistor here. Next, add another component, VDC. In the circuit. Now let us add the ground here and here. Now let us edit the values for our voltage source. Let's change the name of the resistor to R load and change its resistance to 2 ohms. Change the DC voltage source to 24 volts. Lastly, connect the circuit. Now, let us create a simulation profile. Now, let us edit the simulation profile. The runtime should be 80 microseconds. Click OK and run the simulation. Now let us add another plot, so there would be two separate plots for our waveforms. The first waveform can be found by finding the R load voltage. Then, the second waveform is the voltage across the voltage controlled switch. There. From here, you could see that whenever the switch turns on and reaches 5 volts, the voltage drop across the resistor rises to almost 24 volts, since it is 23.988 volts. When the voltage drop across the switch, when the switch is turned off, the voltage drop across the resistor decreases. So it becomes 23.881 volts. The second part of the experiment is done by using a transistor. So let's create a second page for our experiment. One quick way of doing the circuit is by copying the previous circuit and deleting some parts that are not needed for the experiment. Now, let us add a resistor here and place a 1RF IRF 150 MOSFET. Now let us connect the circuit. And check the components. 24, 2, IR 150, and this should be 10 ohms. And change the V2 voltage to 12 volts. 0, 12, 0, 1, 1, 1. Now, let us simulate. Add another plot. Add trace. And voltage across the gate. Add trace. And to be sure, look at the name of the resistor. It says R load 1, while the previous resistor is only R load. So R load 1. There. From here, you could see that whenever the transistor is turned on, a voltage drop occurs at our resistor. On the other hand, when the transistor is turned off, there is zero voltage drop across the resistor. Now let us see the value across the transistor when it is turned on. When turned on, the transistor has a 35.41 voltage drop, 35.41 volts, while R load 1 has a voltage drop of 23.541 volts.
These are the conclusions and recommendations for our experiment.
Conclusion: the circuit was built and simulated using ORCAD Capture CIS Lite for schematic formation and PSpice AD Lite for simulation of circuit. The experiment was divided into two parts. The first part tackled the use of voltage-controlled switch, while the second part was about the use of transistors as a switch for the circuit. From the first part, it was observed that the voltage drop across the resistor is in phase with the voltage drop observed from the voltage-controlled switch. At the voltage-controlled switch, it is observed that during its on state, the voltage drop as seen through the simulation is 5 volts. As observed from the simulation, the voltage drop across the resistive load is approximately 24 volts when the switch is at its on state. On the other hand, during the off state of the switch, the voltage drop across the resistor decreases since a part of the circuit would be considered open, since the switch is off. The second part of the experiment uses an IRF-150 MOSFET to replace the voltage-controlled switch. As observed from the simulation results, the voltage drop across the resistor is in phase with the voltage drop across the gate of the transistor. As the voltage drop across the transistor increases, meaning it is turned on, so does the voltage drop across the resistive load. It is observed that the voltage drop across the gate is comparatively higher than the voltage drop across the load resistance since there is another resistor attached at the gate of the MOSFET. The experiment observed the effects of switches on a circuit. Therefore, a switch affects the output voltage across the load resistor by turning on or allowing the current to flow through the circuit and turning off or blocking the flow of the current. The experiment utilized a MOSFET and a voltage-controlled switch to serve as the switch components for the circuit. Recommendations: I recommend that you check the groundings before simulating, since the placing of the ground greatly affects the output, especially for the case of this experiment where the load resistor is placed after the ground. I recommend that you perform the experiment before proceeding with shooting the video to better understand the procedure and know the basics of the software being used. Check all the components available within the software and determine if an alternate component yields the same result.